Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can before the end of today's webinar. And also at the end of today's webinar, we are doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our two lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is DevOps application patterns on AWS. Our speakers today are Rob Martell, who is principal architect at Explicity, and he's being joined by Randy Defoe, who is principal solutions architect at AWS, and also John Clendenin, who is CEO of Explicity. Welcome, gentlemen. Thank you all so much for joining me today.
Thank you very much.
All right. Well, Rob, I know you're going to be kicking us off, and it's a great presentation, so I'm going to put myself on mute and let you get right to it.
Great. Well, welcome, everybody, and welcome to a topic that hits very close to home, certainly for me and for our company, and certainly for AWS. Biggest question that we pose to ourselves as we go to the cloud is, what about applications? How do we migrate applications? How does that layer in with DevOps? How does that change when you deploy things in the cloud? And we'll try to answer some of those questions today. And certainly there's going to be a lot of open questions, but we're going to step in and we're going to try to go fairly deep in respect to some of the technologies and approaches. As mentioned, I'm Rob Martell. I am principal architect for Explicity. I have been in the IT business for a number of decades, and certainly on the DevOps side, I've been running DevOps teams since the early 2000s, and been involved in AWS since 2007, 2008, so for quite a long time. And Randy, do you want to introduce yourself?
Sure, thanks, Rob. This is Randy Defoe. I'm a principal solution architect at AWS. These days, I'll pretty much cover anything related to AWS, but spent a long time working in the DevOps, the software tooling space, and then a few years ago started switching over to focus more on analytics and machine learning. Been with AWS coming up on 3 years now.
Thank you very much. So we're going to talk through a couple things in this webinar. I'm going to touch a bit on DevOps, and tremendously broad topic, but just kind of put in perspective in respect to the patterns that we're going to be talking about and how to build patterns. We're going to go into detail of what an application pattern is and how we build that in AWS versus how we might build it on premise. We're going to go into some of the details of that application patterns and how to layer in different aspects of a pattern. So how many things should you consider? We aren't going to go in super technical in respect to the technical approaches to pattern building, but we can certainly answer questions on that if people have those as we go through this session. And last thing, how do you manage applications? How do you manage patterns? And go through some of the issues and the ways of dealing with that. Pretty broad topic, so we'll try to get through as much as we can in the hour. So DevOps itself. As I mentioned, I've been involved in DevOps and DevOps teams since the early 2000s. And I remember at that time, my boss had told me and sent me an email indicating that someone had finally named what we did in our organization as DevOps. And it's a growing practice. It is part culture and part technology. Certainly started in the early days and continues as CI/CD and constant delivery and constant integration. It's a very classic definition, but it has gone beyond that. We get into these last few years. We have rolled in DevSecOps, and that's really security practices and how they roll into that deployment model. How do you push security into an operational model? as well as how do you shift left with security. And shifting left, for those who haven't heard that term necessarily, is pushing things towards the developers. Then we get into data ops and how do we deliver data pipelines within CI/CD, and how do you manage data? I mean, code is one thing, infrastructure as code is different, but also how do you handle data? And clearly one of the newest things that has come on in respect to the DevOps world is AIOps. I think it's probably one of the newest practices, and it gets into AI analytics. Because I think it's a fairly natural thing to grow as far as DevOps, but it certainly has been something that people are starting to talk about. So how would I roll that into a pattern? On the left-hand side, you see something that came out of the DevOps report in 2018, the State of DevOps by Puppet. I've read this report over countless years, and I'm sure many of the people listening to this have as well. And in 2008, they talked about a degree of maturity, and I love this diagram because it speaks to that you can be at the beginning and looking, just normalizing your technology stack, or you can be at the end of that journey and providing self-service capabilities. But in all of those things, the key questions still are outstanding. How do you mature what you deploy? How do you automate what you deploy? How do you extend those DevOps practices? And really, it's a degree of maturity, not whether or not you do it or don't do it. There's certainly checklists, and we'll talk about checklists, but we want to make sure that patterns, whether or not they're deployed for application A or the 100th application or the 1000th application, have a degree of maturity. So when we talk about adding patterns for application, it could be a website, what kind of maturity do we want for those patterns? And I think we'll talk about those issues, but we also want to make sure we cover the various practices of DevOps within those patterns. So what would be a definition of a good pattern? Well, I think first of all, you start off with whether or not it has all the components necessary for that specific use case. And certainly people, as they go through their journey within cloud, they can make shortcuts. They can say, you know what, I only kind of need these things, and I kind of don't need these things. I'm going to put them in later. The fact is, a good pattern, a good best practice as defined by AWS within the cloud, or a well-architected framework assessment, says you look at all the components that are necessary. I know it's easy to make shortcuts, but you really should look at all the components necessary and include them in a pattern. Do we consider application codes as part of the pattern? Not for the discussion today. The pattern we're going to discuss today, really, it accounts for it, but it is not part of the pattern. So, simple example, I'm going to deploy a website. I'm not going to necessarily consider the deployment of that code within the web server or the app server, whatever I might be using, as part of that pattern. I'm going to make sure that all the infrastructure has been built, all the deployment practices and monitoring, et cetera, the things I'm going to go through today, but not the actual top tier layer 7 application. That itself can be a pattern, but we're going to build the pattern up without the actual application code as part of it. We want to consider all the DevOps tasks. So every task that could be within DevOps, we want to make sure is part of that pattern as best as possible. And lastly, we want to be able to leverage cloud designs. So, there's a temptation to always do lift and shift. And certainly as a company, ePlexi does thousands of servers in lift and shift modes if we need to. And that's what that makes sense for the client. But equally, when we talk about building patterns, we want to make sure we're going to leverage cloud designs. And because they can be more cost effective, they can scale better. There's countless good reasons to be doing that. So when we talk about building a pattern, we're going to try to leverage as many of those that seem practical. And practical is very important with things with a pattern. You don't necessarily want to be, theoretical about patterns. You want them to be usable, you want them to be maintainable, and you want them to be something you can operate. So Randy, anything that you'd like to add in respect to things that you see as a good pattern?
Well, I think, as you noted on your last slide, that what we're really seeing as a trend these days is, kind of extending the scope of DevOps to more teams. And I think that's an important pattern for people to pick up on. Where DevOps started 15, 20 years ago was really about bridging that divide between software developers and IT operations teams. And now, as you noted, we're pulling in people who traditionally think of themselves not as software developers, but as data engineers, data analysts, data scientists, machine learning practitioners. And the quote you have on the screen there, I think really says it all. There's no way to avoid gaining experience. One of the principal pillars of DevOps is automating and practicing the things that are difficult. So I think you really have to keep in mind that when you get into the really fun, exciting parts about designing data lake workloads or machine learning workloads, that you just can't forget all these things that the DevOps teams have spent the last 10 to 15 years becoming really good at.
Yeah, and I certainly don't think there's anything wrong. And I think we, as a software community and engineering community, know that there's nothing wrong with borrowing other people's experience. There's nothing wrong with leveraging other people's works. You do not have to build things from scratch. You can choose to for a lot of reasons, but whether or not it is part of the experience on your team, whether or not it's tools that bring that experience, or, let me Google it, go in and get what other people have seen, because there are 1,000 ways of doing something, and there's also 1,000 pitfalls, and it's best to stay away from as many of those pitfalls as possible. And certainly those are the things we want to make sure fold into a pattern. So what are we going to talk about? So, as you saw from some of the experience that Randy has and some of the experience that I have on the machine learning and data analytics side, we thought we'd go through a pattern and building elements of a pattern that focus on one of the clearly trending and very important application deployments in the cloud these days, and that's around data lakes. Now, data lakes have been around for a while, and data warehouses have been around for a while, and Hadoop clusters have been around for a while. But as we've been seeing more and more people look at what the investment is on premise, and then look at the huge advantages of building those lakes and analytic systems in AWS, they find themselves asking, what does that look like? Does it look the same? I know what it means to build a Hadoop cluster on premise. Does it look the same? Are the components the same? Could I build exactly what I have on premise in the cloud? Of course, the answer is pretty much yes. Should I is a different question. So we're going to go through simple Hadoop cluster and Spark cluster design. We're going to look at some of the machine learning and AI libraries that you might want to attach to that. Look at the ways of adding Jupyter notebooks. How would I do analytic jobs? What are the things that you might do from a scaling and flexibility and sizing? How I might auto start, how I might do code deployment into the EMR clusters if I choose to do that, which isn't always necessarily the right approach. What I do for machine learning endpoints, what I do with terabytes and petabytes of storage, and how do I get SQL query access? All good questions. We'll touch on each of them at a decent level, but as I said, you can certainly spend hours at 300 and 400 level courses doing and looking at any one of these particular issues. Our focus will be on how would we build a pattern based on this and the things we would need to consider, and that's what we'll go through. So, building an example, as I said, let's say you're looking at your on-premise infrastructure today. You might take this approach. I'm not saying it's clearly the only approach, but you might choose to decide to build your clusters on Kubernetes. Kubernetes is certainly one of the dominant container infrastructure and cluster management systems that you have on premise. There's a lot of complexity to Kube, but I think certainly as a DevOps engineer, you might say, look, I'm going to use Kubernetes. I'm going to run containers on Kubernetes, running my Hadoop cluster, and have that as a separate cluster, and then I'm going to run my Spark cluster. I'm going to have all my storage on those clusters, and I've got all my worker nodes, I've got task nodes, I've got master nodes, depending on what the design might be, but that's what I've got on premise. And if you're a large data analytics company, you could have spent millions of dollars on this. So your clusters, you really have high-end ETL. You've got a ton of ETL jobs. Because you're using local storage, you could have massive amounts of terabyte and petabyte storage. They're attached. You're going to use HDFS as part of that storage system. You're probably also considering using Presto. You might use Hive, but Presto is certainly good for SQL access and HDFS. And you're going to preload. So as part of the pattern building, we're not going to talk about preloading of data. That would be a whole topic unto itself. What is the best way to bring data into your Hadoop cluster, whether or not that's on premise or in the cloud, and that certainly could be a pattern unto itself. So in this design, how would we change this? Or would we change it from a design perspective? Would we use non-relational databases? Would we use machine learning? How would we deal with compute and storage on demand? This very popular design can also be built, as we know, 100 other different ways. One of the things that certainly you could stare at this and say, look, I'm going to run special, I'm going to need to get onto my master nodes. I'm going to have to SSH in. I'm going to need access to that. So there's whole firewall issues and routing issues that are attached to this. And I'm going to have to go through the scaling exercise, assuming that I know what my capacity of jobs might be and how much mapping I need to do on my Hadoop cluster. I'm going to have to think about how far I can scale, because there's no infinite scale here. We have to manage it. So on-premise, that might be a typical application. So question is, what would that first look like on a pattern? Account structure. So at Amazon, certainly best practices say you don't necessarily just jump right in and create an account and start spinning things up. You certainly can do that. But it is best practice to really focus on the account structure that you're going to be using for that particular both enterprise, company, or users. And a very common pattern for that is, and we're going to walk through this in the EMR example, but honestly, it really is not necessarily dependent on the application, is to establish your account structure. And certainly the recommendations that are made, whether or not you're setting up a landing zone by yourself, whether you have a professional services company or organization setting up that landing zone, or whether or not you're using control tower, predominantly fall within the same type of patterns. You have a core user account that holds on to really the master credentials, holds on to root access, has some of the centralized security and IAM role creations and some of the AWS configs. But you're gonna have that core account and baseline at the very, very top. So as part of that pattern, the first is set up your core accounts. So in this particular case, we're going to set up a user account that is at root. We're going to have a security account that is going to contain a lot of the aspects of setting up the security guardrails and controlling access to the sub customer or user or organizational accounts, or not organizations, but organizations within your company. You're going to have a logging account or a log account that's going to centralize your CloudTrail. It's going to could have supplementary logging systems, but it's really also equally for auditing and other aspects. And you're going to likely have a CI/CD account, which could be a shared services account. Those follow AWS best practices, and we certainly recommend that those get set up before you start thinking about broadening out and creating application patterns. Because once you've set up your account structures, it can be sometimes very difficult to go back and then replumb things in. As I said at the beginning, it's better to do some of these really, really important things right at the first step and not necessarily wait and try to catch up later, because, I've seen them, Randy, I'm sure you've seen them, as mixed account structures, OUs that aren't set up the appropriate way, and you have to try to rationalize after you've had this sprawl of accounts and they don't really have a good structure. So, well, like I said, whether or not it's a base landing zone or whether or not it's control tower or any other pattern approach to the top, setting up those core accounts is incredibly important. Randy, do you have any thoughts on that?
Yeah, no, just to reiterate what you were saying there, Rob, I think it's useful to talk about what are some of the problems you might run into if you don't do this. So one thing that I've seen a lot is how developers access log files to help with troubleshooting. So if you have your development accounts and your production environment set up completely differently, the way that developers get access to log data and metrics from their applications could be entirely different. And that could be kind of a rude shock the first time you get called in to help debug a sub-1 production incident. So totally agree. Getting these things right up front will just make it smoother, and it adheres to that principle that the way you deploy in development, and in this sense, we're talking about the full scope of the infrastructure, the environment, the networking, the security. It should be very similar to how you deploy in production.
Yeah, and we later in this presentation we talk about DevOps checklists. Environmental parity is one of the critical items to make sure that you've got. So you don't want to have, as you rightly said, you want to have different logging structures and different account privileges between dev and production, such that when an issue does occur, you just can't deal with it. And equally important, you don't want to have to unravel or unwrap things. As things sprawl, and they sprawl in the sense of accounts and applications, and you realize what you can do, it is better to have a foundation in the pattern that establishes those core accounts first, then creates those supplementary accounts like dev or state non-prod or QA or prod, or however you want to set up those accounts. And there's a number of different ways of how to set up the accounts underneath. But it allows you to commonality, allows you to know where your logs are going, allows the guardrails to be set up. Most importantly, right? If for instance, if there's a company practice that says I should not be allowing S3 non-encrypted buckets to be set up, the last thing you really want to be doing is setting up under every account. Right? You want to set up your guardrails, and you want to set up alerting to make sure if anybody breaks that rule, you understand how to take care of that. So best practice in the pattern is first make sure you've got your account structure set up, make sure you understand what that means. And there are a bunch of different ways of doing that. Again, those can be countless hours of conversations of what the best way for the particular organization to do it, but setting these up is critical. It's the foundation to that pyramid. So next, what would we do next? Well, assuming that our pattern has been created, we've got that base running, we've got the account structure running. I'm now going to set up, let's say, dev. Right? I'm going to set up dev and say I'm going to deploy an application. Well, again, before you start running, make sure that you've set up the core part of that dev infrastructure in the way that you need it to be set up. Certainly, CloudFormation scripting can be done in the previous one, account setups. That absolutely would be recommended and good practice to use CloudFormation for pattern automation and start as part of that. But you also have the opportunity to do multi-stacks or stack sets for a variety of different aspects of creating this pattern. So it doesn't have to be in one massive CloudFormation script. And certainly have seen those and have tried to debug those. And I will say it certainly is a chore. When you know that 99% of the particular stack is working, there's only pieces and parts. So you don't have to think of CloudFormation as a single CloudFormation script. It can be multiple. It can be, and generally should be. One big one becomes unruly. Just like you would build microservices in the software world, just like you would, build smaller Lambda services in a serverless environment. CloudFormation should be built the same way, in small pieces and parts with dependencies and deployment practices associated with those. So in this particular case, a basic pattern, we're going to think about the basics, right? So most people that are, again, going into cloud understand these basics, but it's very important to reiterate it. Public subnets and private subnets, good IP routing, good IP assignments. Making sure that you've got the internet gateways and the NAT gateways in the right places. And then the next piece of that, which a lot of people can not necessarily think too hard about, is VPC endpoints. So for an example, we've worked with a large enterprise client who wanted to deploy a data system, and everything in their world lived in a private subnet, which is great. But they also wanted to use S3. Well, S3 is really kind of routes around and out and back in. It has public access. SQS, public access. DynamoDB, public access. So Amazon has VPC endpoints. So it may be a small thing, but as we build patterns and we want to make sure we maintain the security and integrity of those patterns, if the pattern is everything lives in a subnet and there's no public access, there should be no public access, which is why VPC endpoints exist and why they should be leveraged. Any thoughts on this one, Randy?
Yeah, I agree. This is really become an area of focus because I think as companies are increasingly focused on how to have the most secure networking posture available, they've really started to realize that there's, unless you're literally designing a consumer public-facing website, or some kind of application like that, there's very little reason to ever have any of your AWS resources be publicly accessible over the internet. So there's a lot of ways that you can automatically scan for these, but the best way to avoid any trouble here is just, as you noted, to plan for it up front. So I think we'll see as we go through the slides here, even for things like a Hadoop cluster or getting access to EC2 instances, there's ways to do that without having any holes open in your security groups.
Right, and I'll fall back to the thing that I said before. It's easy to take a shortcut and say, you know what, I'm just going to put this up for dev. And I'm just going to put it in pattern because, you know, it's like least privilege, right? I'm just going to do it this one time. And this one time ends up meaning that your private subnet is leaky, and it really isn't private anymore, and it really isn't secure anymore. But you thought you've done that. You thought you've done all the right things. So we're now going to, so we've set up our pattern. We've set up all the appropriate things. We set up the foundation, again, the second level foundation. So what are we going to do next? Well, what we saw on-premise, we can sort of, we could do the exact same thing, but honestly, there isn't any need to do that exact same thing. Unless, and I'll say unless, and there's a bunch of reasons, but primarily, if you're going to set up Hadoop and Spark clusters, Amazon has a tremendous set of semi-managed and fully managed services that allow you to do that in a fairly automated and a fairly easy way. So in this particular case, what would be the best practice in moving that set of infrastructure to AWS? Well, the first would be if it is, you know, depending on the type of workload, and I'll say there are use cases, and I'll show you pattern number 2. This base case is set up an EMR cluster. So in the case of AWS, when you're setting up EMR clusters, you can run Hadoop and Spark on the same cluster. Heck, I think there's maybe 20 different application packages that you can run on any particular EMR cluster, and variations on that. Some are compatible with what you might have on-premise. Some might extend the features that you have on-premise. But in this particular case, setting up an EMR cluster seems a natural first step. Secondly, it makes a tremendous amount of sense in a best practice pattern to bring the data into S3 for ETL. And use S3 as that temporary storage. And one of the good reasons to do that in establishing base pattern with EMR is that if that cluster goes away, or you might choose to have that cluster go away, your data does persist, and it will persist in S3. That means you do have to reload that into EMR, and the results can be stored in S3 or can be stored in database, but it persists. If you use it in such a way that it is always loaded into the cluster and then never persisted outside of that cluster, then you really don't have an opportunity to take down that cluster. So there's a wonderful feature that AWS has that says you bring the cluster up, you run your workloads as steps, and then you tear that cluster down. Incredibly cost effective, really great for those periodic jobs. But if you don't have S3 stored as part of that pattern, or your data stored in S3 as part of that pattern, that data is going to go away, and you're going to have to, again, go through the process of how did I bring that in. So certainly from our perspective, loading the data in from S3 for the ETL makes a tremendously good part of a base pattern. Master node. Randy said, you really don't need SSH access. There are reasons why it might make sense to have it, but between the use of step functions and Bootstrap, you're more than capable of loading custom jars in. You're more than capable of loading countless steps. So on the worker nodes, which it should say there's a typo, worker nodes, you don't really need SSH access. So you don't need to open up port 22 to the world or to your internal network or VPN. You can leave and close down and run it in a different mode. And certainly we would recommend that as part of that pattern. We would also equally recommend it auto scaling on your workers. So you have a choice, a tremendous choice on how you can scale those workers. I think when I looked at it yesterday and tried to count, there must have been 30 or 40 different conditions under which you can scale. Scaling your workers no longer has to be manual. You can put them on auto scaling. You can look at a tremendous amount of different metrics to scale on. But using auto scaling is a hugely great feature that you get to leverage in the cloud and at AWS. And why is because the more workers you get in some workloads means you get it done faster. And certainly that ETL occurs in a faster pace. And if you're doing machine learning and a large petabytes or terabytes of data and you need to process that data relatively quickly, you really want to scale high on workers and scale back. And certainly, you know, we've both been involved in customers that need hundreds and hundreds of workers, and running that cluster 24/7 is a very expensive proposition. And if you've got to run GPUs, extremely expensive proposition. So workers, scaling, spot price, spot, all are configurations in our eyes that would be work best on this particular pattern. S3 data, as I said, we want to run that over VPC endpoint. Not only is that more secure, but it also reduces NAT gateway costs. So although we do need some degree of access outwards, particularly if you're trying to bring in packages, external packages, if you need to do that. If you don't, then you don't need any NAT gateway. And make sure you've got a VPC endpoint to bring your data in. So then it's riding over more internal networks than the external side. And lastly, again, towards this particular pattern, we want to make the whole infrastructure allowed to be destroyed, meaning it can be semi-permanent, it can be temporary, it can be an hour long. And that means for any of the Hive metadata, we want to store it in Glue. We don't necessarily want to store it internal to the EMR node. Therefore, you can terminate the entire cluster, say once all your steps are done, but your data definitions and all the metadata are external, and you can bring that back up, bring it in from S3, access the metadata from Glue, and run. So now you can have not a permanent infrastructure, but now it's not serverless, but you can have certainly temporary workloads, and you can grow the number of clusters that you might want to have. Any thoughts on this, Randy? Because I know there's a lot to it, but certainly from a base pattern.
Yeah, no, I think this really illustrates one of the important patterns that we're seeing in a lot of areas now with a lot of our customers. And that is taking things like Hadoop clusters that used to be treated as very carefully managed permanent resources, and now treating them as just another transient resource that you can deploy at will as part of your pipeline of building reproducible environments. So I think that's really important for a number of reasons. So certainly, as you mentioned, cost reduction. Hadoop clusters tend to be large, and so you don't really want to have them running unless they're being actively used. I also think it really helps a lot with workflow simplification. So you can have specific Spark jobs or Hive jobs running on different clusters and not interfering with another. It also really helps with security. So, getting back to your earlier point about layering in security into the picture, with traditional Hadoop setups, a lot of times you have to do very complicated things with Kerberos integration in order to have role-based access control. Now you have the choice of having a Hadoop cluster that's dedicated for a specific job and managed by a specific team. So it really helps the overall landscape if you can treat a lot of these things like your Hadoop clusters as transient resources that are managed by automated pipelines.
Yeah, and I was working with a client, recently over the last 6 months, and their production Hadoop clusters on premise were massive. They were working with petabytes of data. But the development teams who had to write machine learning algorithms couldn't get access to them because there was virtually no CPU left. And the loads were dedicated to the off hours. If they got time, they would have to deal with samples. And their move to AWS was all about the fact that even just on the development side, they could run GPUs, they could run it for an hour or two, they could run on supersets of the data, no longer running true subsets, and not at the control of degrading production. So separation of environments, but give development of machine learning, which requires good trainable data, now becomes more accessible and easier to do. So sometimes the move to AWS and EMR clusters isn't necessarily about production, but it is about creating the algorithms that you need and having the pure raw horsepower to do it when you couldn't have done it or afforded it before. So let's look at pattern number 2. So same or similar application. So in this particular case, the ETL jobs that I'm running on the Hadoop cluster, I'm running them as Spark jobs. And that's what I did on premise. Wasn't necessarily a massive amount of ETL, but that's what I had it built up for. So AWS has the alternative approach, which is you don't necessarily have to set up an EMR cluster. You can write Spark jobs using Glue and Glue jobs. So in this case, ETL runs as a standalone Spark job. You can run it as part of workflow. So there's Glue workflow that you can attach to it. There's no real requirement to actually provision master nodes or even worker nodes. You provision based on DPUs. So you set your minimum DPU, make sure that you can grow your DPUs, but you're not really worrying about your master nodes and worker nodes. This data can still be stored in S3, as we said before. The results can be stored in S3, or it can be sent to Redshift or other types of databases as the endpoint. You can do the same thing from access point. You're going to access S3 through a VPC endpoint, and you're going to do the same thing from your metadata. You're going to store it in Glue. So similar, but now different in the sense that it is truly a serverless environment. In other words, everything disappears. You're not even provisioning the servers. You're not worrying about them. You're not worrying about, do I worry about spot pricing or not spot pricing? You just you set your minimum DPU threshold, and you make sure it sets for auto scaling, and you deploy your jobs. That same Spark job, could take 2 minutes. It equally could take 4 hours. And certainly have watched a number of jobs that run on a very long period of time, doing a lot of production, dealing with a lot of data. But the customer simply didn't want to manage or worry about EMR clusters. So in this pattern, same sort of Hadoop cluster that might have existed on premise now becomes virtually serverless. There's not any permanent infrastructure or permanent compute in this particular version of that same pattern. Any thoughts on this one, Randy?
Yeah, this is really an interesting pattern, and I think it illustrates a lot of the architectural decisions and trade-offs that are important to make as you're moving a workload like this onto AWS. Certainly with Spark with Glue being a fully managed service, it simplifies a lot of operational aspects, and it means that you don't have to worry about when to scale clusters up or down, when to turn them on or off. You just run your Spark jobs and away you go. But there are, of course, some important differences, both in terms of logging, application development, and cost. So those are worth taking a look at as well. But I think I would say, at least for dev test workloads, unless you know for sure that you're going to be running a very large Spark job in production, Glue is really worth taking a look at because it simplifies the picture so much, particularly, again, for those smaller dev test type of workloads.
Yeah, and I certainly think those, as you rightly say, those are the early architectural choices, because you can do these things in many different ways. One always has to have an eye towards cost. One has to have an eye towards what the end use case is. There is no necessarily a single pattern. So what you may have set up on premise as being, a single Hadoop cluster, I'm going to run everything I need to do on that cluster. When you move it to AWS, your choices are very broad, and you can design your patterns specifically, again, using the same foundations to the use case. And it doesn't necessarily hurt you because you're not making investment in equipment, right? If you don't, this particular case, you use this once a month, that's okay, because you're being charged on a DPU per hour basis. It doesn't, outside of the cost of building it, doesn't really attract much cost. So things that we did from the lift and shift pattern. We don't really need to use Kubernetes. We can run Hadoop and Spark and other types of workloads. We shift to EMR as pattern number 1, and we shift to Glue as pattern number 2, depending on the use case and all the other factors that an architect will look at. EMR runs within the same AZ. So, one of the practice you might do with a website is spread it across AZs. Well, in the case of EMR, you don't do that. It's designed for faster processing. It all rests in the same AZ. If you need HA design, then then you deal with the second thing, which is, well, maybe you run 3 master nodes instead of 1 to deal with some of the high availability. Not sure why the line is duplicated. Again, Hive doesn't need to be on a separate system. Certainly, we think it's a good practice to have it external to a Glue catalog, but it can also equally run as it does on premise within a cluster. We don't need external access, likely. So we don't need open up 22. We can keep it in private, and we don't need container orchestration. So these changes from lift and shift have made it, have reduced the degree of management, have reduced the complexity of the application. And now we can spend a little bit more time looking at the other aspects of DevOps that we're going to apply to that pattern. So we have a core architecture. We have some of the core elements. So how we build on all the things that we expect out of a DevOps operation, and how do we build that into that pattern? So I'm going to talk just briefly about SageMaker. So now we've got access to data. Can we throw SageMaker in? Well, SageMaker itself can be a pattern, but we're just going to layer it in We're going to add SageMaker setup, both the compute side as well as the network side, making sure it can talk to the appropriate components. We can choose between virtual compute or leverage the EMR cluster, again, based on the resources and what we're trying to do and how much compute we need. In this particular case, this pattern is going to leverage the EMR resources that we set up in the first place. We are going to need some outbound connections, likely for packages, and bring those packages in. If, on the other hand, you can use exactly what is part of the SageMaker images, then you may not need external access. And lastly, and equally important, we have to think about what happens when we don't need it. And in the case of notebooks, it's really easy to sort of keep the code on the notebook and not necessarily, you can stop it, but don't shut it down. Well, one of the best practices and good parts of the pattern is leverage code commit. Pull the data, pull the notebooks off code commit, make sure you've got the storing of the new notebooks back in code commit so that you don't necessarily lose it. And I can't tell you how many times I've watched a notebook go from stop to delete, and someone say, where'd the code go? And I said, well, that depends. You hit delete, so it's gone. So let's find and make sure, as part of good DevOps practice, that code, even if it's part of the setup of this particular case notebook, there's a point of that notebook back to Git or back to a code commit and make sure that code is stored. Now, SageMaker and SageMaker Studio have had tremendous advancements over the last 2 years. So I'm going to super simplify this for this sake, but I know, Randy, it's certainly been a huge investment that AWS has made over the last 2 years in making SageMaker as sort of a dominant part of the machine learning infrastructure in AWS. Any comments?
Yeah, that's right. I think you'll continue to see more of that investment in the future. One of the really interesting things about SageMaker that you mentioned is SageMaker Studio, and that really introduces another choice in the way that folks collaborate with their Jupyter notebooks. So I think those of us who come more from the software development background, we naturally assume that Git repositories, source controlled repositories, that's the place that we store data for making sure it's preserved and being able to share it with our team members. I think what we found, though, there are some folks that come more from the data science background where that's not necessarily the way that they prefer to work. So SageMaker Studio provides just a shared file system that provides automatic backups. It's based on EFS, so it has all the characteristics of durability you'd expect. But it makes it easier to share just through making snapshots of notebooks and sharing them with other users. So I think this is another interesting question of, based on the users you're targeting, you want to account for the way they like to work in the architecture.
Yep.
And as you know, you have to make sure their data is safe, but now you have a couple of choices, particularly on the data science side.
Yeah, and then certainly the product announcement, I think it's still in preview out of the East region, the studio, but I know having some of our clients see it and use it, it's a huge difference between just pure SageMaker and of all the features that have been added into it. So we are at about the 20-minute left, so I am going to speed up just a touch to try to get through the majority of the pattern and the other components. So in pattern number 2 is equally there is a way to bring in SageMaker, slightly different. In the case of Glue, you're going to set up a thing called a Glue endpoint to attach SageMaker to it. One of the things that you find as you go through this, and again goes back to the experience part, so you definitely look at Bootstrap and lifecycle policies to start up SageMaker and not necessarily always keep the Glue endpoint. So for instance, the Glue endpoint, if you don't have the SageMaker notebook running, Glue endpoint is still there. So in our case, CityPlexity, we write specialized Lambda policies to shut down that Glue endpoint and only have it running when the notebook actually needs it. And really dealing with the aspect of cost is very important to consider. Don't just keep running everything all the time, and that's why temporary infrastructure, making sure things shut down, and if they don't shut down automatically, then sometimes that means custom code to be able to turn things down and make sure that you aren't using cost when it isn't necessary. So how do we layer in things like CI/CD? Well, if we go back to that beginning pattern, beginning of the pattern, we set up a shared services account as part of the organization, and that had our CI/CD pipelines in it. So in this case, instead of trying to set up pipelines in every single account structure and customer account, we centralize the pipeline process within a common account. And so you're from code commit through code build, code pipeline, and code deploy, all the good tools that we currently have within AWS. We push that CI/CD process using cross-account roles into each of the environments that are necessary. So now we have one pipeline and one pipeline system. We have a common element to it. We can, whether or not it's deployed to dev, staging, non-prod, prod, common place for that pipeline to occur. We have a common place for code commit to occur and the code to be stored. And now, as part of the pattern for this application, we make sure that we've got the configurations required to build that, that pipeline as part of the pattern. And that means deploying the infrastructure as code. It means deploying specialized Lambda functions that are needed for lifecycle policies. It means deploying everything and anything that's needed for that pattern. Again, we are not talking about the highest level of code here, the application code. We want to make sure that if we decide to change a policy, we decide to change the configuration of the Hadoop cluster, that rolls through a CI/CD process, that rolls through all the way through CloudFormation, deploys it, and is just as we would deploy code, we're going to deploy this pattern in a CI/CD mode. Next thing we're going to layer in is DevSecOps. So very, very important part, certainly on the data side, that we adhere to the security policies of whatever the organization is building it. So there is a long list of things that we need to maintain. Some are done when we set up, whether or not it's that we set up those base accounts and the guardrails. But in this particular case, we need to make sure that we're doing linting on code, and that can be done within the code build side. We make sure that we've got inspector set up on any of the EC2 instances that are permanently assigned to the clusters, and making sure that there's any CVE scanning that's required. We make sure that we've got SSM secrets holding on to passwords. Again, it's super easy to put those passwords in code. And as part of the pattern, we make sure that SSM is set up, the secret definitions are set up, and the code references that. We make sure we've got agents running on the worker nodes and on the master nodes. We make sure SSM is set up, so to be able to ensure that you've got the ability to manage those systems and run commands remotely. Again, going back to the need to SSH in, if you've got SSM set up, you've got agents set up, and you're using Bootstrap or using steps with an EMR, there really is, it's hard to make the case that I need to set up port 22 and all the aspects of that. And always making sure S3 is encrypted. Now, I'm glossing over security. There's a tremendous amount of things that you want to make sure that in a pattern. AWS has a tremendous set of best practices for that. Everything from should I be using Macie on S3 because it could have PII data, to how I separate and encrypt the data, roles, access rights. All those, as part of the SecOps part of DevOps, should be embedded in the pattern. They should not be part of some external process that you think about, because those are the reasons that people might make mistakes and leave something open or unencrypted or a key available and unfortunately stored into code commit or GitLabs, whatever it might be. DevSecOps integration pattern is essential. And thoughts on this one, Randy?
I'll just mention quickly that there is a new well-architected lens published recently on both machine learning and big data. So if you're looking to dig into some of these recommendations in more detail, those white papers are a pretty good place to start. They just capture a lot of the best practices that we've learned from our customers over the last few years.
Yeah, and this is a place, go back to one of that first statements, experience, leverage people's experience, see why things have failed and what you should not do and what you should do. Because the last thing you want to do, remember one of my bosses once said, and working for a large enterprise on the East Coast, is you do not want to be on the front page. So data and security is in the end the #1 job, right? It cannot be exposed and should not be treated with any more importance of how we set up an EMR cluster and ensuring that we've got security established. AIOps. So how do we fold in things like ops and AIOps? Well, the one thing that you've done at the beginning is you've set yourself up to have a common place where your logs are coming in, your CloudTrail, your CloudWatch itself, and you can set up log drivers to push that data out to someone like Logic Monitor, which could be your external monitoring system, as well as it could be your AIOps system to look at interpolation of those particular logs. So by having a common place, we've set up that pattern, we've given that foundation of a common log place. Now with the appropriate security and the appropriate auditing, we can push those logs out to SaaS providers that give us even higher levels of log visibility and issues associated with it. And again, those logs could be used for anything from monitoring CPU to looking at errors to looking at other, whatever the patterns might be, or using predictive analysis to determine what problems might exist. But you created a pattern that makes that join of that log driver out of CloudTrail into whatever that service might be. Could equally be Splunk or anything else. Now I can feed it from a central place. So is the pattern complete? And with 10 minutes left, I would argue it isn't. So what else should we be doing? Well, as we know, DevOps it's a growing practice at the beginning. We've talked about continuous integration. We've talked about operational integrity and deployment. What else is left? Well, at Aplexity, we spend a lot of time doing DevOps checklists and DevOps readiness, and everything that's sort of surrounded in red: design patterns, deployment pipelines, continuous integration, operations. All those are part of the DevOps practice, and there are more. And this happens to be readiness checklists that I did quickly over the pattern. Things that are in green, we probably covered. The things that are in orange, we did not cover or did not cover in completeness, which means we need to look at those as well. And again, by adding them into your first pattern or your second pattern means you can then leverage them into the next pattern. So I'm going to take a couple of those quickly. So if I needed to, add application monitoring. So in this case, CPU monitoring for clusters, storage usage on EMR clusters, the threshold for the execution jobs, whether or not they're glue or EMR. What are my thresholds for auto scaling? Am I getting close? Am I getting nowhere near it? What is my DPU utilization? All of those go into application monitoring and then become part of the pattern. They can be CloudFormation scripts. Sometimes they need to be Python scripts, but you add those into your pattern. And we didn't add a lot of those into the pattern we discussed. We did add auto scaling. So IaaS scaling absolutely was in there. I would say you can do more scaling. You can make sure idle resources are not used and control your costs. Cost management. One of the great things about AWS's cost and billing system is it not only can you establish thresholds, but in your pattern, if you set up your tags appropriately, you can set up tag alerts. And you can tag your applications with tag A, and if you can set up a budget against an application. So every application can have its own tags and can have its own budget. And therefore, in this particular case, my spend to date is a particular value. I'm at $2,000, and this application might be well within its threshold, but another application could be well over. So we do not have to look at billing at a top tier at the account level. Now we can get down into billing and alerting at the very, very granular pattern level. So billing becomes an element of that pattern. CVE scanning we covered, and we can sort of escalate the amount of CVE scanning, but in a very, very critical part of SecOps. I want to pause here just for look at questions. You want to maybe get a couple of the questions posed so we can cover those?
Yeah, sure. We can go ahead and do 1 or 2 questions here, and then we'll have to. We've got about 6 minutes to the top of the hour, so.
And I've got 1 or 2 wrap-up charts I want to do just after questions, and then I think we'll be good. So.
Okay, all right, great. So let's go ahead and take a look at the first question here. Any advice on using config management tools like Chef and Puppet with AWS ASGs?
I think that it depends on what kind of configurations that you want to do, but I think as mentioned, I didn't really get to talk to it earlier in the charts, was that Chef and Puppet are great for configuration management, should be considered as part of patterns. Certainly auto scaling and other aspects of scaling services outside of auto-scaling can be drawn and used within Chef and Puppet. Depends a lot on whether or not you want to introduce that for the first time or whether that's part of your DevOps practice today, but certainly would encourage to continue to use those tools as part of your pattern. Randy?
No, I agree. I think Chef and Puppet are, if you're already using them for doing things like patching of your virtual machines, by all means, continue to use them.
All right, great. I think we have time for one more question here. Regarding the account setup, it seems difficult to have all requirements up front. How about starting with MVP and expand on that?
So
I'll jump in on this one.
Yeah,
I think, yeah, as Rob noted a few times, you don't have to reinvent the wheel. So there's a variety of ways to get started with what we call a landing zone or an account vending machine solution without having to do it all from scratch. So I think what I would consider the MVP is kind of captured in the AWS landing zone concept, which is now actually part of the control tower service. Rob, I'm sure ePlexity, I know you folks have built similar things for your customers as well.
Yeah, 100% agree. I think to me, MVP is setting up those 4 common accounts, setting up the root account, and then getting any sort of vending machine running. Because undoing that and doing something different 6 months down the road after your accounts have sprawled it's a tough mess to get out from underneath. And having had to do it, it's tough. And it's it'd be better. It doesn't take a lot. As you said, AWS provides some great tools that can deal with that right off the bat.
Okay. All right. We are about 4 minutes to the top of the hour. Unfortunately, I think that's all the time that we have for the questions, but please know that the folks at ePlexity will be getting a copy of all of the questions. So anybody who didn't get their question answered during today's webinar, I'm sure they'll be more than happy to follow up with you offline. So Rob, you said you've got about two more slides,
Yeah.
2 charts to go, and then we'll wrap it up.
Yeah, so at ePlexity, what we've done to equally deal with the pattern issues is we have developed a product called CXOS, which gives us one-click access to patterns. So all the patterns that we build for our customers, all the managed services that we do, we use a product called CXOS, that is internally built by our company, that provides instant deployment of those patterns. So once the pattern has been built, it can be reused and reused and reused. And the ability to hit that one click and do everything that we spoke about, whether or not it's deploying aspects of the core accounts, whether or not it's spinning up an EMR cluster with SageMaker and all the other pieces and parts, we make sure that not only are they part of a pattern that is well formed in AWS Cloud Architecture, but it also adheres to AWS best practices and the well-architected framework. Certainly as a company, there is you can download our DevOps pattern ebook, which is available, and that is something that's worth reading. If you'd like to explore more patterns, certainly visit us for more information, and we'll do a no-cost well-architected review and learn what a well-architected review is, making sure that your AWS infrastructure is well structured and can support all the things in the future. And certainly, if you want to speak to myself or one of our solution architects about AWS DevOps projects or how CXOS, our product that makes pattern deployment super simple, please contact us at info@eplexity.com. And I wanted to thank everybody for listening today, and certainly thank Randy and Charlene and Brian for the time today.
All right, great. Well, thank you, Rob. I do want to, real quick, before we close things out, do the drawing for the $250 Amazon gift cards. So our winners today are Bob B. and Kevin C. Congratulations to you both. We will be following up with you by email after today's webinar to get your gift cards to you. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, you will have the opportunity to access it on demand. We will be sending out an email today that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Gentlemen, thank you so much for such a great presentation, chock full of information. And judging from the number of questions we did get from the audience, I know they got a lot out of it. So thank you again for your time. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.